In the previous presentation, we had discussion on the basic circuit element inductor. Now, in this presentation, we will be discussing some important points about the inductor, in which the first one is for DC sources, the inductor will act like a short circuit, or simply we can say that inductor allows DC current. So, by DC sources, we means that for which the terminal voltage is constant. And for DC sources, we also know that the current for DC sources is also constant. Constant current is flowing in the DC circuits. So by short circuit, we means that for which the terminal voltage is 0. And also the resistance of a short circuit is also 0 ohms. And the voltage is 0 volts. Now, as we know that the voltage across the terminals of an inductor is equals to LdI divided by dt. So for DC sources, the current through the inductor will be constant. So this equation becomes V is equals to L d. I in this case is a constant divided by dt. So the derivative of constant is equals to 0. So the voltage induced across an inductor for DC sources will be equals to 0 volts, which is the property of a short circuit. So it means that inductor allows DC current without any resistance. By without any resistance, we means that we showed the resistance of this inductor by a term called impedance. And the impedance of this inductor is represented by XL. So the resistance of this inductor is represented by XL, which is equals to 2 pi F into L, where F is the frequency of the DC voltage source or the current through this circuit or the current through this inductor, and L is the inductance of this inductor. So for DC sources, we know that the frequency is equals to 0 Hz. So as a result, the impedance of this inductor will be equals to XL will be equals to 2 pi, and the frequency of a DC source current is 0 into L. So the impedance of this inductor is equals to 0 ohms. So it is also the property of a short circuit. It satisfies the property of a short circuit, that the impedance or the internal resistance of this inductor is equals to 0 ohm, and the voltage across the inductor is also equals to 0 volts. So it means that the inductor will act like a short circuit for DC sources. We will be discussing this XL term in a more brief way in the RL transient phase of an inductor. Now moving towards the second point, which states that inductor will not allow any sudden changes in current. So by any sudden changes, we means that for which the rate of time is equals to or approaching to 0. So by sudden changing in current, we means that for which the change in current is finite. So as we know that V is equals to, for an inductor, the induced voltage is equals to L di divided by dt. So L di in this case is finite. The rate in the current is finite, while the rate in the time is 0. So the voltage induced in this case is equals to infinite volts, which is impractical or impossible. So the sudden changes in current is impractical for an inductor, because it requires an infinite amount of power to generate a sudden changes in the current. So as we know that the power equation is equals to V into I. V in this case is L di divided by dt into I. So L I di in this case is finite, while dt is equals to 0. So the power required for the sudden changes in the current is infinite watt, which is impractical or impossible to provide an infinite power to the circuit. So it's all for today's presentation. If you have any doubt, ask in the comment section. See you in the next one.